Good afternoon, everyone, and welcome to Taco Tuesday. Today's topic is deep dive into Taco's expansion tanks. Today's Taco Tuesday will be presented by Brett Zerba. My name is Rich Medairos. I'm one of the senior systems engineers here at Taco. And I want to just cover a couple of things about the company and then some housekeeping items, and then we'll get right into today's presentation. So a little bit about Taco, for those of you who may not be familiar. This is a family-owned company owned by the White family, currently headed up by John Hazen White Jr., who is the third generation of the White family. And he, along with his senior management team, headed by Cheryl Merchant, who is our global CEO, have done a fantastic job navigating through this COVID period. And so we're very grateful for all the hard work Cheryl and her team have done to keep us on the straight and narrow. Well, a couple of housekeeping things. Oh, just one other thing about Taco. For those of you that may not be familiar, Taco originally stood for Thermal Appliance Company. Thermal Appliance Company. So if anybody ever asks you what did Taco originally stand for, it was Thermal Appliance Company. And we are just over 100 years old. We celebrated our 100th year anniversary last year, although we didn't do any physical celebrating because of the COVID crisis. We hope to do some functions this year, later on, perhaps the third or fourth quarter of this year. And we do have factories scattered throughout the globe, including in Asia, in the United States, Canada. We have factories also in partners in India and China. So just a couple of quick housekeeping things before I turn it over to Brett. We do have 5 handouts. If you click on the handout section, you can look at those 5 handouts, and they include such things as, I just had the list here, our CA catalog, our CBX catalog, our CA instruction sheet, CX instruction sheet, and PAX catalog. Good reference material for today's discussion. And you can download that from the handout section. Just to make sure that you can hear me and see our introductory screen okay, if you could wave your hand, it'll pop up on our attendee list. And raise your hand. Yep, I can see several folks. Thank you very much for that. So we have quite a few people that will be attending today's discussion. So if you have a question, please type it into the question area. I've seen a few folks say hello. So we know that the questions are section rather is working. So if you could just type in, say, hi, Rich. That way I know that you can hear me and that the question box is also operating. Yes, I've got a couple of high riches in there. Excellent, thank you. Okay, so what I will do, I will be acting as today's moderator. And in a moment, I'll turn it over to Brett. If you do have questions, we will stop periodically and try to answer your questions. And we'll do it in real time rather than waiting for everyone to, or rather to answer your questions at the end. And I'll ask Brett to pause periodically so we can answer your questions. So with that in mind, a couple of seconds, I'm going to turn it over to Brett. We're going to get started. So Brett, could you say a few words about yourself and then start the presentation?
Thanks, Rich. Appreciate that introduction. Hi, everybody. As Rich said, my name is Brett Zerba. I am an applications engineer and a trainer is in my title as well. And I've been with the company almost 25 years. I graduated in 1981 from the University of New Hampshire with a degree in mechanical engineering. I'm a legacy. My dad graduated in 1961. Actually, I was born while he was finishing up his civil engineering degree. I digress. Well, one other thing, housekeeping-wise, 24 hours after today's presentation, you'll get an email, or you should get an email with links to the recording and a PDH hour certificate if you're eligible for that in your state, and you can utilize that. And if you don't get it, just let us know. Let's see, what else do I want to let you know? Well, today's presentation is, as it says right in front of you, deep dive into TACO's expansion tanks. And I'm going to show you a couple of slides on what I'm actually going to be talking about. But many of you have sat through one of our presentations, actually Rich's presentation, on how to size expansion tanks and select them. Although I'm going to show you the app towards the end, that's not the focus of this one. I'm really going to try to break down the details of the expansion tanks, how they're made and fabricated, material construction, some of the options and repair parts and stuff like that. So it's more on that side of the components, okay, than on the more maybe technical or selecting them and whatnot in the system. Although I am going to get into installation and show you some drawings, recommended drawings that actually you can download from our website. And one of the things I'm going to do is to let you know what those initials that Rich said, those catalogs and instruction sheets were, what they meant. You know, Rich and I deal with these on a daily basis, and I've seen some familiar names. My good friend Jason up in Ohio is on. I know he knows those letters as well as anybody. But you folks, many of you may not know what those are, so we'll have to talk about those as we get going. So, but please, as many of you have done in the past, these presentations are so much better when you ask some good questions, or any question, and Rich will bring them in and we'll get them answered today, tomorrow, or down the road. So let's get going. Let's get started. Expansion tanks. Well, here's some of the stuff I'm going to cover. Types of expansion tanks, material of construction, performance data, features, installation information. Maybe not real detail, but enough to show you some detailed drawings and some recommended locations and stuff like that. I am going to show you the selection app, and you know, I think most of you know I work for TACO, but guess what? It's the best selection app for expansion tanks out on in the marketplace. It's so daggone easy. And then some questions at the end. So that's pretty much what I'm going to be touching on. And by the way, the expansion tanks we manufacture are really for two purposes. One purpose, right, for the expansion of liquid, but for the HVAC hydronic industry and maybe some potable water as well. So there may be other types out there in the industry, but that's not the focus of TACO. As many of you, if not most of you, realize, we deal in hydronics, right? Mostly clear water for the most part. So that's what HVAC, heating, ventilation, and air conditioning. One of the first things I want to at least mention, and probably most of you, maybe 99% of you, understand why an expansion tank is required in a closed loop hydronic heating system. And you can read the paragraph, so I'll paraphrase, but the bottom line is water, or that mixture that's in there, mostly water, but there could be some glycol or something like that. As it heats up, it expands. So if there's no place for that to go, it's going to increase the pressure in the system and try to find a way out. And if it gets up too high, or there's too much pressure increase in there, something bad's going to happen. A component's going to pop, a relief valve or something like that. Something bad is going to happen. So that's why expansion tanks are important, and they're necessary. So in this paragraph, it says heating up the water. So some of you may think, well, do I need it for a chilled water? Because I'm not really heating up chilled water. Well, what happens, and Rich and I have talked to individuals that this has happened to before. They design a system, and it probably was undersized. I think they had it in there, but they put on an expansion, don't, or put on a small expansion tank for a chilled water system. Well, guess what? There's times when that chilled water system may not have the chiller running, especially during installation, right? I think many of us, if not all of us, have been on projects where the piping's done, the water's filled up, and the chiller isn't turned on for 6 months, 8 months. Well, daggone well that it's going to see 100 degree, or could see 100 degree temperature. So that same phenomenon of the water heating up. So it's not just for hot water systems, it's for chilled water systems as well. You want to add anything to that, Rich? Because I think you fully agree with that statement.
Yeah, I think so. I think that's the right the right guidance to give folks.
Excellent. So here's some of the types of expansion tanks, right? Bladder style tanks, and then you can break them down into full acceptance or partial acceptance. And I'll show you some diagrams and explain what's this terminology mean. Diaphragm style tanks and partial acceptance. There are partial acceptance tanks, and then you have plain steel tanks. One of the important distinctions between the top two, bladder and diaphragm, or three, however you want to count, in the plain steel is in those other the top ones there's a definite separation between water and the tank itself. All right, there's an air cushion in between. In a plain steel tank, the system water is actually just in that tank. So that's one of the big distinctions. The diaphragm or the bladder captures that water. And this is one man's opinion. Maybe other people agree, maybe some people disagree, but this is my opinion anyways. Plain steel tanks are the old style, right? We see very few on new systems, and that's what I'm going to say. We still manufacture them because they're direct replacements, although some of our reps and suggest to folks maybe you should replace it with another one, but nonetheless, something to consider that. Diaphragm style tanks are okay. They work if you size them correctly, but they are throwaways. What I mean by that is the diaphragm, and I'm going to get into the details of that, cannot be replaced. So if there's a failure of some sort of that component, it's a throwaway. So they're okay. They work maybe in smaller systems. I have some good friends out there on the rep side of the business that say maybe 20 to 50 gallon type systems. They'd suggest you put in a diaphragm. And you know, there's price differences, right? You have to get into all of that as well. And then partial acceptance bladder style tanks, they're better, right? They allow you a little more flexibility. When I say partial acceptance, and you'll see what I mean by that, that there's a tank, right, with a volume, and that bladder inside of it doesn't fill up the whole volume when the water comes in there. So there's some sizing issues, maybe a little bigger, up to 100 gallons, maybe 200 gallon type system. You might want to use a partial acceptance. The bladder in a partial acceptance tank is replaceable in the field. And then to me, the full acceptance bladder style tank is the best from a engineering standpoint, from a project standpoint, and whatnot. And but you know those top three, I go best, better, and okay. Well, the pricing is in reverse, so just keep that in mind. And probably most of you realize that, but nonetheless, but I want to emphasize, if it's sized correctly and installed correctly, any one of them will work in your system. Okay, but to be quite honest, once you get above you know, a couple 100 gallon type system, 500 gallon systems in the water, the full acceptance is probably the best way to go, just from based on size and whatnot. So just keep that in mind. Let's see if I can move forward here. So here's a picture of a full acceptance bladder tank. There's the tank on the left, and there's a bladder that gentleman's holding. This is actually at our facility where these are manufactured in Fall River. This is probably a PAX tank, the way that bladder looks, but that's a partial acceptance bladder. So that would not actually take up the whole volume of that tank. And here's a diaphragm tank. Here, that gentleman's actually holding the diaphragm that would be welded within here. That's a top connection. This is a bottom. No, this is a top. All three of these are top connection. The other, there is a bottom connection for one of the CBX tank, but I'm not showing you that in this condition, in that picture. So types of expansion tank, bladder style tanks. So here's another picture, full acceptance. And it's the TACO model. God, we're this far into the presentation, and I'm finally telling you what a TACO model is. It's a CA tank, TACO model CA tank. So there's different sizes, as you can see here, and you can see some fittings on top and some other components. And I'm going to get, I got some other screens that'll get into the details of all of those. But there's a cutaway. There's a cutaway of an older tank. I could tell it's old because it's green. Funny story about that. When I first started at TACO, our pressure vessels, our tanks, we sent out green. And hopefully all of you realize that TACO is the green pump manufacturer. I hope. But anyways, products like this, when they are moved through trucking and shipped and installed and whatnot, they get dinged up, they get scratched, and there's a beautiful new system building. And as you're doing your final walkthrough, you see all these nicks and knacks all over a nice tank like that. So contractors were forever trying to get paint from us or from the source to match it, and it was always a pain. So our intelligent folks at our facility in Fall River said, you know what? We make these tanks that look like Rust-Oleum here. Most people can get that if at their local hardware store to match that, so they can touch that up. So that's the reason we changed from green. If I digress, but nonetheless, a kind of a story we tell when folks come to our facility. But you can see this diaphragm here would fit and fill up that whole tank. And so the water goes on the inside, the air cushion is on the outside. So here's some of the performance data. I'm going to spend most of the time on the CA tank because I think it's the best one, and from an application standpoint, but it's big, right? It can go up to almost 4,000 gallons. And trust me, if you needed a bigger one, our good friends in the Fall River facility would do their best to make it if they could get the bag for it. That's for sure. But nonetheless, there's the capacities. You can see how small it goes down to as well. To be quite honest, and anyone that works for Takeo, don't listen to me right now. But personally, if I had a system that only needed a tank 23 CA that small, I may look at an alternative. But that's just me. Heights, imagine this, it goes up to almost 24 feet tall. So some of these tanks can get very, very big, as you can imagine, once you start looking at the gallonage and whatnot. Working pressures, I mean, that's really system design. We have all different ratings there. It's just a different coding, and our rep friends out there can help you make sure you get the right coding there. And that's described in the catalog that's attached as well. We can even go up to higher operational pressures. We don't see too many, but maybe on a high rise or something like that, possibly, or something like that. Pretty high operating temperature. That's the maximum operating temperature. Shame on me. I didn't put in degrees Celsius. I apologize for my good friends north of the border or outside the US, but I forget the formula. 5/9 plus 32 or minus 32, 9/5, whatever it is. Sorry about that. Anyways, and then optional up to 280. So there are some options here. Maybe a couple pieces of material of constructions that are a little different. But nonetheless, that's the performance data for our CA expansion tanks. And to be quite honest, I think if you go to our competitors' charts as well, or their information, you'd see pretty much similar availabilities. To be quite honest, this is one of the more important bullets that I feel in the presentation. All of our pressure vessels are designed, constructed, and tested to they're pressure vessels, and they get the ASME stamp, American Society of Mechanical Engineering, Section 3, Section 8, right? Is that I took that class in 5th grade, right? The Roman numerals, Division 1 requirements. So that means we have folks on staff that are trained engineers for ASME, an ASME engineer on staff. We actually have an incredible testing procedure that all has to be written up, and we have an independent tester that monitors our facility. He actually has an office at our facility in our Takeo Fall River facility, and he monitors all of our testing and the paperwork on a daily basis, so we can continue to get our stamp. It's pretty intense to do, but really. Hopefully most of you have that in your specification, because these are pressure vessels, and God forbid something ever happen, but if it's not constructed correctly and a big tank is under pressure, bad things can happen, and God forbid anything like that happens. But our Fall River facility has some incredible welders, and they do a heck of a job there. And the bladder itself is a heavy-duty butyl rubber bladder. So that's something to consider. But pretty common. It's very flexible, forgiving. So something to remember there, and it's field replaceable, and if it's installed correctly, these bladders should last upwards of 20 years, 15, 20 years installed correctly. Please just keep that in mind. Normally, it's carbon steel construction, normal carbon steel construction. You can get stainless steel system connection as an option, or stainless steel construction as an option as well. So we'll make the whole tank out of stainless steel. Actually, at our some of you folks may have been to our facility, and when Rich tours, when one of us takes you on a tour, hopefully we can do that next year or at the end of this year. But anyways, of our great new mechanical room there, we actually have a stainless steel. Well, no, that might be a 4900, but we have a big stainless steel tank up in our facility up above as well. And this is a a key fact for Takeo. I think it distinguishes us from some folks. All our fabrication is done in our Fall River, Massachusetts facility. As some of you hopefully know, our headquarters for our worldwide company is located in Cranston, Rhode Island. In this facility, we're talking New England states now, Rhode Island and Mass. So everything's we're all pretty close together here. It's less than a half hour away from our facility, and the welders there, I put them up against anybody. They are fantastic guys and gals. NSF ANSI 61G certified and listed is optional. That makes it for Potable as well. So some of the features that you could expect on the TA expansion tank, CA series expansion tank. But by the way, some presentations or talk, I'm going to give you some other bullets here, some installation information as well. But another name for bladder style tanks is actually captive air, because there is a caption of air in there. So that's just another name. Don't let anyone, in our industry, until I got my feet on the ground, there's so many names for the same thing. It made my head spin. So just keep that in mind. It's important to know all these basic names as well. And this is Rich made this comment when he talked about expansion tanks, and hopefully other folks have, and it should be in your detailed drawings, but it should be located as close to the suction side of the pump as possible, at least that connection. That's the lower pressure change, and that's the reason why you want to do that. Our standard product, our carbon steel product, can come with a 304 stainless steel cover, and if it does like that, it can be rated for maybe used for potable water. So our reps can explain that in more detail for you, but the CA with the stainless steel cover can be used for potable water if required. We have a whole series of those as well, our PAXs, but I'll get into that shortly as well. These here can be installed horizontally or vertically. As they get bigger, most of them I see installed vertical, but you can. I have seen some installed horizontal, so that air cushion can work in either side. And then the ones that are certified for potable water use, so that NSF, right? That NSF certification are required to be mounted on the cold side of the hot water tank. And I'll show you a detail of that further into today's discussion. That's because, and all of us are up against that. Not up against it, but that's how you can get certification. It has to be cold water. It can't be hot water in order to get that NSF certification. We recommend a combination shutoff valve and drain valve should be in the connection of the piping coming to the tank. And I'm going to show you a detail of that as well. That's for isolation and draining of that. So that's something to consider. Our offering has optional anchor clips. So as it gets bigger, those anchor clips would probably be a good idea. And that's all spelled out in the catalog, and you'll see some pictures of that as well. And then in order to meet some California requirements and other folks as well, we do offer an optional bullseye sight glass, which is available, so it allows you to at least see in there in case there's something catastrophic going on. So some of the other bullets of our product line that can be described. So, hey, Rich, how are we doing for questions? I've been yapping for a little bit here.
This is a good place to pause for a second. We have a couple of good questions. So one is from Abdul, and he is asking, he says, why a diaphragm is needed in the expansion tank? Can't we use the stainless steel tank without a diaphragm? So why do we have a diaphragm in a stainless steel tank? That's a great question.
That's a great question, and you could use just a stainless steel tank, but what happens is then um, the sizing comes into play, and that diaphragm keeps the water, the system water, from the tank, which it separates it out. So that's a good reason there. And because there's air pressurization in there, that it helps sizing of the tank as well. You have anything to add to that, Rich?
Yeah, I think you covered it, and I think we should mention that the bladder or diaphragm actually creates a separation between
Right.
the fluid, which in most cases is water or water glycol, and the air.
Right.
So it does not allow the air to go into solution inside the expansion.
I mean, and to further that statement, air into water in hydronic systems is a bad thing. It's a bad thing. It can cause issues as it flies around the system for components and pumps. We know it'll cause some systems for pumps. So here's
So we
just a
have another
kind of,
question, which I thought this one's from Sammy. This is a great question. I would not have thought about this question, but he's saying, why would you need stainless steel tank if water is in a bladder and no direct contact with the water? That's a great question.
that is a great question. I think some people, it could be in a corrosive environment where they locate it. Um, um, uh, or sometimes folks step it up because they're looking for a little prettier looking tank. Any comment for you? I know we sell them, but I'm not sure 100% why folks would want them.
No, that's a good point, Brett. I think I've probably seen only a handful of stainless steel tanks manufactured in Fall River. It's pretty rare, and people do have their reasons for using them. But he makes a very good point. The
Yep.
fluid or water does not come in contact with the metal, and so yeah,
But on the outside, it could if
it
if
could.
it's in a corrosion. Depends where it's mounted.
Right.
But so anything else? Or should I move forward?
Well, there is one here. It says, is there a different material in the bladder when comparing Taco's expansion tanks to other manufacturers?
Um, that's a great question, and I don't know what other manufacturers have. I know what we have, and maybe your rep, Taco rep, a local rep, can tell you what other folks have. We feel we have top of the line bladder material. So
And one last
captive.
one before we go back into the presentation. Why can't you have a removable diaphragm by way of a flanged joint? Removable diaphragm.
Yeah, that's these tanks are very small, and that diaphragm is has a ring around it, so it's permanently mounted to a ring, and that ring is welded into there, and it really it, it's not worth the expense to go to that next level to make that removable. I'm sure the guys looked at it, or the team looked at it at one point, and for what the market bears for those and how small they are, it's just not worth it.
And then let's do one last question, Brett, before we get back to the presentation.
Yeah.
Because how often do bladders need to be replaced? Do they break down over time?
Everything in an HVA system breaks down over time. But if we have, there are many out there installed that have been running for over 20 years. I think ours is designed to last upwards of 15 years, 15 to 20. If it's installed correctly and operates correctly, it should give you double digit amount of years. But so a lot of times it's what it's installed in and what it ends up seeing, and stuff like that. Anything to add to that, Rich?
I would say the same thing. Yes. In fact, the majority of bladders that I've seen have not had material deterioration over time. Usually there's a tear in the bladder for one reason or another. Something sharp inside the tank that was unanticipated. It's pretty rare to see a bladder fail. So yeah, I would agree. They, for the most part, they last a very long time and very, very, very few failures over the life expectancy of these things.
And by the way, I've seen folks replace a whole tank instead of a bladder in the field just because of the cost difference. One of the instruction sheets I show you, or oh no, I didn't. I can only have 5 handouts, but there is an instruction sheet that explains the actual process of how to replace a bladder. And you know, it's not quite like replacing a light bulb, to say the least. But
So let's
here's
get
just
back into the presentation. There's a few more questions, but I
yeah.
think they might get answered or we'll pick them up again in another minute.
Okay. Yeah. Otherwise, I'll only get through 10 more slides. Anyways, here's a pre-pressurized air cushion. So, you know, on the left-hand side, as the system's filling, right, there's just a air cushion in there. And then under operating pressures, that water expands into that rubber bladder, and the air pressure kind of holds it as much as it can. So that's kind of the pressurization process. I, I can't emphasize this enough in a presentation, and our technical staff at TACO, the Fall River folks, and Rich and I, you know, invariably once a month or whatever, uh, the pre-charge, right? We talk about the pre-charge, that pressurization that screen just before us just showed. The pre-charge has to be properly set in the field. It has to be checked and properly set in the field. Okay, you can read this paragraph. I don't have to read it word for word. That's not the type of presenter I am. But we send it out at a 12 psi pre-charge, because that's about, well, we can go a little higher over the road, but the trucking laws only let us go so high. And Rich has talked about what how you determine the minimum fill pressure that needs to be for that pre-charge, and it has to be adjusted prior to connecting the tank to the hydronic system. Rich and I have been on projects where we've had to supervise people didn't set it properly. We had to take it off the system, and then you got to drain the tank. You got to get all the air out and then restart it. It's really a pain in the neck. Okay, and that information, and Rich has defined this before, and he's been a consulting engineer in his time working. That should be on the schedule or within the job specifications. And if you're a contractor out there and that's not available, you got to go get it. Really, I can't emphasize this one enough. Uh, uh, but that's all I'm going to say. Moving on. The pre-charge, and invariably, you want to ruin a bladder or waterlog a tank, or worse, don't set the pre-charge to the correct number. Here's a picture, and kind of explaining a lot of the components. So that item 1 up top here, that's the Schrader valve. That's where you can adjust the air or add air to it. Item 2 is just a label. That's where the system connection is. There's that item 3 is a hose assembly that can get the water into the tank. 4 is the bag itself. Item 5, okay, and we're going to have another discussion from my high horse on this as well. Do not pipe this to drain. Actually, if you look in this paragraph down here, removing plug voids tank warranty. So that plug should just stay there. That's if the bag fails, or you got to empty the tank out of all the water that's in there because that bag failed. That's not to, you don't want to do that going to drain, because invariably you take that cap off. First off, it could be dangerous, right? If you don't do it properly. And number 2, you put a valve on there, and as these tanks, as the water heats up and cools down, right? I'm going a lot faster than it actually does in reality. Invariably, that valve is going to let go of its seal over time, even though it's a shut-off, hard shut ball valve or whatever type of valve. And sooner or later, the air is going to seep through there, and that you're going to lose your charge. So do not pipe that to drain. We spell it out in our instruction sheets. It's called out, but put it on your drawing or whatever. Do not pipe the drain. And there's some action, optional anchor clips. There's a kind of the side view and a straight-on view of the bullseye glass, and then the lugs. So the bigger ones have lugs for lifting as well. And then here's a blow up of the nameplate. And we're going to talk about the nameplate, but there's the detail that's on that. So that information allows the rep and TACO to get more information. So an ASME vessel has to have documentation forever associated with it. So that gets you all that information associated with that as well. Here's a recommended kind of old style drawing here. There's the suction to the pump. And I'm showing an optional of 2 or 1, but and some people pipe them in parallel or together or whatnot. We can have a discussion about that. But there's that isolation valve and good piping practice, a union in there so you can separate it without having to cut the pipe or anything. And there's that drain fitting there. So really, that's pretty straightforward. But that is that valving that I was talking about in an air vent on top. Here's another style acceptance tank, and this is our CBX model. This is a partial acceptance, okay? And this bladder looks a little different than that picture I showed you earlier. So this is actually mounted from below. The water still goes on the inside of it, so the system connection is at the bottom. But this is a partial acceptance, and I think most of us, just by visibly looking, can see that bladder would not expand to fill up the whole tank. So that's the difference between a full acceptance and a partial acceptance. But that is the TACO model CBX, a lot smaller, right? The other one was close to 4,000 gallons as its maximum. This one here only goes up to 121 gallons. So again, for smaller systems, right? Smaller systems. And you can see the diameters there. What the other one was almost 24 feet. This one here is just over 7 feet high. A lot lower working pressures. We can give you optional ones as well. It's just probably different welding. And the maximum temperature is 240. But again, all of our expansion tanks, pressure vessels are made to that ASME code. I can't emphasize that enough, and I'm going to emphasize it every time I show you one of our expansion tanks. The same type of material, that bladder is the same type of material, that heavy butyl rubber. Partial acceptance, and again, field replaceable. So these are the last two. No, the PAX is field replaceable as well. All the fabrication is done in our Fall River facility. So we bring in the steel, and it's an incredible process. And I recognize some names on the attendance list. So some of you folks, some of our guests have seen this facility. It's incredible what they do there. And they have machines that can bend steel like a piece of paper in a cylindrical shape up to 1.25 inches thick. It may even be more than that now. These tanks aren't that thick, but nonetheless, they can bend steel up to 1.25 inches thick. And they use, for many of the tanks, they use the submerged arc welding. Saw is the process. It's semi-automatic, or it can be all automatic. And it's not your typical welding where you see a big arc. There's actually a gas sheet, a powdered flux is generated, and it kind of keeps the bright lights from going there in the fumes. So it's quite a process how they use them at that facility. And the welders at our facility are just unbelievable. And there's that CBX, bottom connection. So the piping's a little different, but it's still on the suction side of the pump. These diagrams are on our literature on our website. Okay, so some of you may be taking pictures or whatever, but they are on their website. By the way, the CBX is vertical installation only. So just keep that in mind as you look at it. PAX for potable water expansion tanks. Okay. And these are not diaphragm tanks. These are partial acceptance bladder style tanks. And if you remember the size of the CBX, that 132 is the same. So probably the outside is very close. And the diameters as well as the height. Working pressure is a little lower. It's not really required that much for potable water, but you can get up higher if you needed it. And my maximum operating temperature is 240. But again, that ASME, you know, a lot of this is repeating, but it bears repeating. It really does. I can't emphasize this enough. And these folks, the welders at the Fall River facility, I mean, I've seen them do welds for like 8 hours on one big component back and forth. It's just phenomenal, some of the things they do. The PAX has to have stainless steel system connections. So it does have stainless steel system connections. That bladder and that tank is that heavy duty butyl rubber again. If you remember the picture, okay, so I want to make sure we look at these pictures. So let me go back. This is the partial acceptance CBX bladder, okay? See how it's mounted from the top, bottom like this? Well, let's picture way back. This picture here is the PAX one. That's actually mounted from the top, so it's a top connection. So there's kind of the difference between it. It is a partial acceptance, but nonetheless, you can see the difference between the two. So I wanted to at least point that out as we look at these. Okay, what else? Again, some of this is repeating, but it needs to be repeated. These are nationally board registered, and CRN, that you can get a CRN, Canadian registration number on these PAX tanks as well. And the NSF, they don't have to be NSF, but if they are, they get certified and listed, and that's an option that's available on the PAX tank. Non-NSF. So the non-NSF PAX tanks are suitable for vertical or horizontal installation. Okay, the non-NSF ones. And again, I know it gets a little confusing. You get these letters, NSF, PAX, CA, CBX, but your TACO rep can walk you through it, or our factory can walk you through it if you ever had more questions about it as well. And again, to reemphasize, the models certified to NSF are required to be installed on the cold side, not the hot water side. Optional anchor clips and optional bullseye sight glass to qualify for the California code that's out there. The left coast, are they the left? No, the right coast. The other coast, the West Coast. The West Coast guys have a requirement, so something to consider. I did want to emphasize these are PAX style tanks, partial acceptance, but these are our micro expansion tanks. So, you know, for a residential application, notice how the size is here, only 2.6 or 6.6 gallons, very, very small, 40 pounds, 52 pounds, even this old guy talking to you right now could probably pick these up. But they have a heavy duty replaceable bladder. We got quick ships options on these. So, you know, and it's still an ASME vessel. A lot of other compliance here. California code compliant with that glass here. And there's your working pressures and whatnot. It is fabricated steel, but the connection is stainless steel, and that's how you can differentiate yourself to get the NSF requirement. And it has a little air charging valve at quarter as well. And how are we doing for questions, Rich? I'm ready for a break. I need a sip of water.
Cool questions out there. I believe you answered this one, but let's answer it again. Why would you want a partial acceptance tank?
That's a great question. And I want to go on record as saying that if the tanks are partial, full acceptance, blah, 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 diaphragm are designed and installed correctly, they work, right? They work. Why would I want a partial one? Because I'm cheap and I want to save a few bucks on this small commercial job I'm putting in, or a large residential project. I shouldn't have said it that way, but that's a possibility. Or here's another reason why I want a partial acceptance. I'm under the gun to get a replacement and get someone back up and running, and it's the only one that I can get in overnight. I've done that before to help people out as well. So there could be a schedule issue in that regard. But really, as I kind of said, when you get into smaller projects, maybe you would think of a partial acceptance. Anything to add to that, Rich? I kind of beat it to the to the death, I
No,
think,
that's
on
the
that one.
yeah, that's they're less expensive. That's why a lot of people specify them. And in a competitive market, you need to offer a full range of options for folks. Okay, one more quick one before we go.
We as a Yep, go ahead.
So
Yep.
one more quick one. Uh,
Uh-oh.
it says,
Yeah.
what would be the easiest way to diagnose a bladder failure um, in the tank? Would it be the optional sight glass? I
Um,
actually have an answer that I'm going to add to whatever answer you give, Brett.
I, personally, I don't. I hate to not agree with the personal sight glass, but isn't it with the fitting on top, Rich? You can answer this one better than I can. I forget.
Yes. So if your bladder fails, then eventually, immediately, if the bladder, let's say, has a hole in it, then the water will fill the cavity between the bladder, and over time, the uh, the air that's in the tank will go into solution, and the tank will become waterlogged. And that's usually when the people figure out that they either the safety relief valve goes off because the water won't expand anymore. There's no place for it to expand. And the easiest way to check that is right up here where it says number 1, the charging valve. If you that's a Schrader valve, just like the valve on your car tire. And you press that in. If water comes out, the bladder has failed. So that's the simplest way in the world to find out if the bladder has failed. Simply press the Schrader valve open, and if water comes out, the bladder has failed. As simple as that. Okay, let's
Simple,
continue, and
sweet.
we'll add a few more questions later.
Yep. So we talked about these little potable water ones having to be mounted in the correct location. Well, here it is. Here's a water heater, so it's on the cold water side. So the NSF one has to be rated mounted over there. And if you go down, well, if I go downstairs, this is a similar piping arrangement than that I have at my house. Believe it or not. Here's a recommended installation for heating system, chilled water applications for the PAX tank. It's really being installed just like a CA tank or the CBX, not the CBX, as the CBX has the bottom connection, but the CA tank as well. So here's a picture of the expansion tank, the CX, the Takeo model CX tank, the diaphragm style tank. And again, partial acceptance, okay? Top connection again, but you can see this ring in here, so it's welded in, and again, it only goes up to 132 gallons, so I don't know what that translates into a system volume, but they don't get very big. They don't get very big, and you know, yes, we could, you know, think about cutting and flanging like was suggested during this presentation, and find a different way to mount this in there. But the return on an investment, I don't believe, as you look at it from as a business standpoint, would just justify it, to be quite honest. And as I said, the gallonage, these are relatively small for most applications. Not for use with potable water, so the CAX cannot be upgraded to be used with potable water. It can be installed horizontally or vertically. That still has the same material there. Limited acceptance, so you know it only can accept so much in there, and in the right application for the money, they work like a champ. So just keep that in mind. Again, ASME rated is located there. The diaphragm is rated to 125, the standard one psi. All you know, some of these bullets are the same for all our features, but I need to repeat them because you know, we're a United States manufacturing company located in Fall River, Mass, for our welded products division. So you know, it's something to be said. And here's just a diagram of what a common, a lot of these diagrams look very similar as well, but you know, good piping practice, right? I don't think you could put enough unions on a job, to be quite honest. But nonetheless, you can kind of see some recommended locations there. And then you have some other alternative locations, maybe the different way to pipe it in or whatnot. And then, you know, a double pipe in over here on 2. So there's different alternatives there. And you know, if you ever had some questions, you could talk to our technical folks to get clearance there, or the TACO rep in your area or territory. They would be able to understand it as well. Here's the last style, right? And I call these the old style, right? That's me, though. That's Brett Zerba saying, to me, it's the old style, and I think hopefully most of you can agree with that. But you may be exposed to them, you may go out on a project, and I'm going to show you a picture of one. You say, oh, okay, I understand. That's a plain steel tank, and that's our TACO model plain steel tank. And here's kind of a cutaway of an older one here. So all of them, or the majority of them, have a sight glass. The majority of them, right? I always get into trouble if I say all or whatever, but they have a sight glass, and that just shows you it shows you the level of the fluid in there. That's what it is. And then this is an air control fitting, and this helps with the air control that's in there. That's actually where the water comes in, and the air comes into it, but it gets above the water, so it works and breaks the seal internally of the water. So that's kind of a pretty neat fitting. And then there is a tank drainer here. And again, it has to get outside of the water in there so it can help drain it. But that's a tank drain. So there's kind of a cutaway of one. And these are just supports, right? Those are just supports holding it up. They get pretty big, but don't forget that 515 gallons, half of it, 3/4 of it's all water, right? Because it's an air. There is no separation of water and air in there, and that's one of the main reasons why the industry went to that and saving space as well. And they get pretty big. They can get pretty big pressure-wise as well. Oop, looks like a typo over here, Brett. You missed it. PSH. Who caught that? I'm sure Jason did. He's pretty good at telling me what I. Not for use with potable water, but nonetheless, you can see that there. Again, ASME, non-bladder type design. Okay, I want to emphasize that. All fabrication done. You can get it is nationally board registered. CRN registration can be happening as well. But this is what I wanted to get to this. Wait, this is ways to identify a plain steel tank, right? Location, always up high. The CAs, CBXs, they may be mounted on the floor, many of them, but you can mount them up high. But these here always need to be at the top of the system. So gauge glass, right? More than likely you would see a gauge glass on these. Like I said, you go into an old mechanical room and someone's saying, I want to replace that piece of equipment. Boom, boom, it's an old style. Well, it may not be a PSS because it could be our competitors, but it's an old steel stainless steel tank, or excuse me, not a stainless steel tank, but a plain steel tank. And then you would see some type of air trawl or tank drain fitting mounted on those tanks as well. So that's how you differentiate those. To be quite honest, save yourself, if you can talk people into going to the new one, even if on a replacement job, look at that. But direct replacements, they sell themselves too, that's for sure. Something else that's important to at least mention during this presentation is the TACO. Well, I was thinking tanks and TACO, so I combined the two words. The TACO expansion tanks and commercial products, and we talked about about a month ago when I talked about the base mounted pumps, have NFC tags on them, near field communications. And what they are they're static pieces of equipment that don't need any power, but that has a bunch of information attached to it. Okay, so all you need to do is tap your NFC tag for product information and support. It's eLink. It's eLink TACO connectivity. Excuse me. And if you have the right app on your phone, you can actually just put your phone right over that green thing, and it will provide you order and product info, replacement parts, sales and support contacts, drawing information, more information than this right here. It has all of this information that's on the tag itself. Excuse me, on this ASME tag, but nonetheless, it has more information than that. And this is a differentiator for TACO. We're the only folks out there, so feel free to put that in your specs if you'd like. That NFC tags are required on any commercial products. I digress. But TACO connectivity, NFC tags are installed on our commercial products, and you can kind of see where they are here, right? That's a plate and flame heat exchanger. That looks like an expansion tank of some sort. Both of these do here. Yep, that says CBX there. But nonetheless, you can kind of see where they are. And actually, I think we put them in more than one location because unfortunately, people peel things off for whatever reason. But nonetheless, our commercial products, including our expansion tanks, have the eLink TACO connectivity. Any questions, Rich, before I go to the app?
Well, there was one I thought was kind of interesting, which popped up. Why do you need PRV on the makeup? And I'm going to answer the second half of this question. Does TACO offer PRVs? And yes, we do offer PRVs, pressure reducing valves, but generally they're specifically for the residential market because they're relatively small. I think they only go up to like 1/2 or 3/4 of an inch, that sort of
Right.
thing.
The water pressure needs to be regulated prior going into the system. Isn't that the correct answer, Rich?
Well, the PRV establishes the minimum fill pressure.
Right.
So yeah, that's important.
And you know that one of my screens that I harped on about pre-charge and that minimum fill pressure or minimum pressure system pressure, it is so important for these bladder style tanks. So please, if you take anything away from this, learn more about it, get some more information from somebody. You know, it's hard in a presentation like this to cover it 100% so you understand it. Matter of fact, if we had time, I'd turn it over to Rich and he could do a Boyle's Law equation right on this blank screen in front of us. But nonetheless, it's so important to make sure that that pre-charge is set. So I'm not going to spend a lot of time on tank sizing. We had a great presentation that previously, and we may run it again on how to get all of this information. But the app that I'm going to go to, here's the information you need, right? And we talked about minimum fill pressure. And I put some numbers on the right-hand side, and they're going to show up on the screen. But maximum pressure, right? That maximum system pressure. And there's different numbers there, and there's ways to calculate it and whatnot. Minimum temperature, maximum temperature. Chilled water, use 100 degrees. Chilled water system, use 100 degrees. Minimum is what your fill temperature is. Well, you know, ground temperature, 40 degrees, 50 degrees, 60 degrees, depends where you are or whatnot. And then the one everyone always says is the hardest one to get is system volume. We have some software that can help you get that. There may be some quick methods that other folks may suggest you can use, maybe even some of our reps do, but nonetheless, you do need the system volume. And then system fluid, you need that information as well. And then you can go to our tank sizing app right on our website. You fill in that information, and it brings in a bunch of selections for you. And since, what is going on here? Since I want to show you, I am at our TACO website. I will go to selection tools, right? And we hopefully some of you have seen this before. And one of them is expansion tanks. And there's that, I ran through that screen very, very quickly, but here's that app that we need to fill in. And it gives you some ideas over here. You can actually change the pipe material. Personally, from a conservative standpoint, I leave it to copper because it adds a little more flexibility to the system. Actually, I probably should use it the other way around. But then you would need to change your system fluid. Very, very important. Very, very important. In that regard. So let me put in those numbers that we were shown there. And I'm not going to. Oh, look at this. This looks new, Rich. Have you ever seen this here? I'm gonna put.
Yeah, this is cool.
Yeah. Huh. See, Rich and I, we get lost in the weeds sometimes, but nonetheless, boom, it has brought up these particular models that are shown here. You have access to the submittal, the catalog, the instructions, the Revit drawings. It shows you the tank volume, it shows you acceptance volume, and there's a CBX. What do we say about that? That's a partial acceptance, right? So it only has partial acceptance compared to that, and those numbers are actually shown over here. Here's the system volume. It's roughly 54 gallons, right? And so this one's 61, so that works. How about this one down here? This is the CX, right? We could use a CX for that. How can I use that? It's only 27. Well, you got to use 2 of them. And you can use 2. if you'd like. So matter of fact, you can cut this in half and use 2 of the CAs. So you can play a lot of games there, but it depends on size and getting it into the room and whatnot. So that's really up to you in that regard. But this app is not hard to use, very, very easy to use. And all you have to do is go to our website. And we talked about Project Builder before. We recommend you get in there and all that. But nonetheless, boom, that's how easy the app is to use. Well, Rich, it's 1 o'clock.
It's 1 o'clock. So I
You got
think
one last
at this
question?
point, you want to try one last question? I think you answered this question, but I'm gonna bring it up. Why 100 degrees maximum for chilled water?
Because what happens on many projects, on a chilled water project, is when the project is installed, the chiller isn't turned on, but the system is filled with water. And maybe it's filled with water in May here in the States, and it's not turned on because the system's still being worked on or whatever, and it sits idle through the hot months. And what happens to that water? That ambient temperature goes up to 100 degrees or maybe even higher. So that's why we recommend, or many engineers recommend 100 degrees, if not a little higher. Be conservative. Be conservative. God forbid. And I still remember, Rich, a year or two ago, we had, 2 or 3 years ago, we lost all last year. We had a gentleman in there, and it happened to him on a project, or he was involved with a project, and he said, yeah, that happened to us. So
Yeah, and I
anyways,
think it's important to, depending on where you are in the world, your ambient temperature might be higher, in which case your fluid temperature could be, like Brett just said, could be higher than 100 degrees. So it depends on where you are in the world. If your outside temperature can get up to 120 degrees, that's pretty hot. It's possible that the fluid could get to 120 degrees. So yes, 100 degrees or higher for considering the maximum water temperature for a chilled water system. Well, Brett, we're out of time. It's 1:02. Do you want to say a few parting words before I say goodbye to
I do.
everyone?
Thank you, everybody. I appreciate everyone's questions. And thanks for listening to me. And like I said, there's a lot of information on our website. Take a look at the handouts, and your TACO reps or our factory can even give you more information if you need it. Bye, Rich. Bye, everybody. Hopefully you can still hear me.
Yes, we can.
Oh,
So at
good.
this point, I'm going to reiterate what Brett said. Thank you so much for listening to our TACO Tuesday presentation. We will be answering the questions that we did not get to live today. So look for that information over the next roughly week. And at this point, I'm going to sign off and say thanks again, and really, really appreciate you taking the time out for our TACO Tuesday. Take care, everyone.
Bye.